here. I redid everything on the website, the whole layout. I didn't redo the layout, but I redid the images, and I think it doesn't look good still, but at least it probably looks better than before, and it is a lot faster. And I think that's what matters the most, actually. If it's fast and it has good content, I think people won't care about the rest too much. And what I'm gonna do as well is I'm gonna use Medium for getting the fonts and the style of the article, which I'm probably gonna do now. Maybe I'll do this off stream because this is easier with the two monitors, and I'll work on the. I think that's a better strategy, better thing to do. So I'm going to work on this article, the first article that I didn't look because I was trying to solve all the other stuff. And I created this hamburger component that is responsive and was a little bit annoying to do. And so this is how it looks right now. And I'm also gonna put some margin here on this because it's annoying me that it's too close to the thing. Yeah, I don't know. Maybe I will put only on this one. It doesn't change anything. And put a very big number. I think it's because of the width of the div. Oh, now it went. There's a little bit of change there. But it looks like maybe it's this one that has to be. This has to be with 100%, but I don't think it's gonna change anything. Whatever. I think I will leave it like this. And then when you do this thing here, then it becomes this button. And then this looks pretty ugly, but I didn't want to spend a lot of time styling this thing here. And I use ChatGPT to help me with this. It's super annoying to do. And I don't think it's gonna matter too much as well to rank on Google. So I'm gonna watch this video here and then I'm gonna work on the article. And I wanna replace first all the files. I think I'm gonna do one article for each, just so I have one for each. But I wanna focus more on algorithms and blockchain. But I think I will do enough articles to replace all of them. And this one is pretty useless, I think. Because I'm not supposed to have any articles on the top level, I think. So what I'm gonna do, I think I'm not gonna follow this strategy. They updated the terms of service of this extension, and now they are requiring you to share all the history. Oh yeah, I was using ChatGPT to help me with the resume because I also don't want to spend time doing that. And because they changed this, so now they are requiring you to share your prompts and the stuff you do with everyone else. which is understandable, but I'm not. I don't want to do that. I think maybe I will at some point, but I think the strategy that I'm gonna follow, and it's probably better, is to do choose ChatGPT, but to do it on my own way because I already know what kind of stuff that I want to learn and that I think will be interesting for people and that they will search for. But obviously, it's gonna be an ongoing process of studying and researching keywords and using ChatGPT to create the articles and then refining the articles until I think I'm satisfied. So my plan for now is to, after watching that video, is to go one algorithm by algorithm, and then I'm gonna read what ChatGPT gave me here yesterday, and I'm going to search for the code for the algorithm, and then I'm gonna try to understand the algorithm, and I'm gonna try to see if there is anything that I can change in the ChatGPT's description of the algorithm. And I'm gonna do this for all of them. And that's gonna be the post. And then I'll move on to the next one. I think the next one is gonna be I'm gonna try to do the archetype of all these 20 graphs. So if I would write the solution for all the problems, different problems only one time, how would I do that? And that's the question that I'm gonna think about.
North Face duffel bag, there we go. So let's say we have a niche affiliate website. It looks like these North Face duffel bags are pretty popular. Let's go on Google and let's see how competitive it is. So all in title. Oh, really? Interesting. Let's do in title instead. Oh, wow. Interesting. Okay, there we go. Yeah, I don't know. You could be worth doing an article on best duffel bags or just on a review on the North Face duffel bag, for example. Pop-up truck camper. I actually don't know what that is. What is a pop-up truck? Do they sell them on Amazon? That's the important question. Amazon. Because if they sell on Amazon, it's easy.
You can watch this later. I'm gonna put some music and I'm gonna do this thing. Let me quit Discord. Oh, there's also something really interesting that I realized and I was thinking about, which is you can generate API keys for Midjourney. So that might be an interesting thing to integrate with the blog, because I can use I can make an NFT generator. But then again, the only issue is that I would want to avoid as much as possible to do anything related to NFTs that doesn't involve any utility. So I would have to think about a way to integrate a picture in the way that it wouldn't be just like speculation and gambling pretty much. I'm gonna start this thing. Also have something on my wrist, I think, from typing too much. It's kind of annoying. Maybe it is from the gym as well. I think I spend too much time typing. It's kind of addictive. I still suck at it. But my time is improving very slowly. But I think I hit a plateau. But look at this. 124 hours, I think, typing. Fucking crazy. Not the best time improved, but it's very hard after some points. You start stagnating. Ah, fuck. I almost had it. Damn. Yeah, I had this a couple of times where I'm almost there, beating the record, and then in the 3 seconds, 3 last seconds, I make a mistake, and then the most difficult part is not making a mistake, because mistakes will slow you down a lot. I think that's what matters the most. JavaScript algorithm is a graph search algorithm that solves the single source shortest path problem for a graph with non-negative edge weights, producing a shortest path. This algorithm is often used in routing and as a subroutine in other graph algorithms. The basic idea behind the algorithm is to relax the edges of the graph one at a time. The algorithm starts at the source vertex and repeatedly selects the vertex with the smallest tentative distance from the source vertex, and updates its neighbors with the new distance if a shorter path is found. We maintain 2 sets of vertices, a set of settled vertices whose shortest distance from the source is finalized, and a set of unsettled vertices whose shortest distance is still being calculated. Initially, all vertices are in the unsettled set, and the source vertex is moved to the settled set. The algorithm then repeatedly selects blah blah blah. Yeah, don't wanna read this stuff. Also wonder if I should do both 2 languages or like Python and C++. I think that might be a good idea, but it might be not a good idea as well. Maybe like this, Python, then it puts this. Also don't know exactly how each language is supposed to be written here. Yeah. Okay, so first it gets the nodes from the graph, then is looping here and adding the nodes to the shortest path with the max value. And then the start node is 0. So it creates the same graph with the 0 for the starting nodes and the max value for all the other nodes. So if the value of the current one is smaller than the value of the ones... I don't understand that. If statements... Now node is the current one in the loop and the current min node is none. Yeah, if it's none, is the same node. And on the other iteration is gonna be... It's only gonna replace if it's smaller than the one that already are greater. I don't understand this loop here very well. It's hard to visualize what's happening. It's looping through all the unvisited nodes, and then the first time the node becomes the one in the iteration. But then it compares the previous one with the current one, and if the current one is smaller, then this one becomes equal to the current one. But why though? Oh, it's doing this so that it jumps from the current one to the one that is the smallest around the current ones. But that doesn't make a lot of sense to me, because or maybe it's because I don't understand the structure really well, like how they are connected. Because in my mind, when you get graph.getNodes, you're getting a list of all the nodes, and there is no way of knowing if the edge exists between them. And that's probably wrong, because I don't understand really well how they are connected. And let me look at ChatGPT. is, I think, is a lot easier to understand than the other example. Not visited. Yeah, so if the U is bigger, it becomes the current one. So it starts off as infinite, and then if it's bigger, it's gonna become the current one in the loop, I think. But I'm not really sure. But this is probably accurate because the I is on this here, which is the list of all the nodes based on the length of the graph. So it's a list of infinites based on the length of the graph. Then the visited is a list of false based on the length of the graph, and then it starts at 0. Yeah, so after this it marks as visited, but shouldn't this be on the same? No, it's because it's doing the loop for all of them at each iteration of the bigger loop, I think. So it's checking to see for every node, if every other node in relationship to that node is bigger or not than the current one. Yeah, the only thing that I don't understand is the connection between them, because if you do it like this, I don't understand how the vertices are integrated in this. Because this is just the list based on the range, which is the length of the graph, but there is no information on whether the edges of the nodes of the graph are connected through the edges or not. So in my mind, you can't go from one edge that is not from one node that is not connected to another node that doesn't have edges directly connecting them. So how are we gonna compare them with this thing here? Doesn't make sense to me. So it's using U as the the other thing is that this is gonna be infinite always, because the distance is a list of infinite. So it's never gonna pass this condition here. And this doesn't make sense to me. Because U here in the first iteration is gonna be infinite, because it's never gonna pass this condition. Because all the elements here are float infinity, and U is float infinity as well. So this is gonna be the index or index is not gonna exist. I'm gonna create a file just to see if it works. And the problem is that I have to create the graph then. I guess I can just create a NumPy matrix. But that's the thing. It's also hard to understand because if I create the matrix, then it's only gonna get one dimension of the matrix as the length. To the adjacent list graph. Oh, now I get it. So the outer list is the one that has, and that's the reason why it's using the length there. So it knows it's gonna, all of them are connected because that's the nature of the graph. That the outer list is the one that has the vertices, or the vertex, and the ones inside of the nested list are the ones that are the neighbors for that vertex. That's the thing that is hard though, because there's probably so many implementations that it's difficult to know which one is the optimal one. think I understand the logic, but it's kind of hard to know if I thinking the correct way. It's kind of hard to understand this part here as well because it's abstract. But I get the, let's say, the general logic of it, where you initialize everything to infinity, and then you go, and the first one's gonna be 0, and then you go one by one, and then you replace the ones that are smaller with. So it starts off as infinity, and then let's say the value of one node is 50, then the current one is gonna become 50, and it's gonna do this for all of them until it finds the smallest or shortest one out of all of the other ones. I think that's the basic logic, but I don't understand really well the nuances of how to apply this with these loops. Because I guess I'm having difficulty understanding because it depends on the type of graph as well you pass. It's kind of hard to imagine like what is the best way to do this and how the graph is represented, because like maybe that's a good question to ask. Is there standards for creating graphs? Not sure. And is the first. And that's the challenging part, I think, because there's so many different variations of what you can do. It's kind of hard to understand. I'm trying to figure out why. Like, what I want to get at is where did this problem come from, and like what is considered to be the best approach to solving. Because if there are many ways to implement the algorithm in many different sorts of graphs, then what's the best? How would you go about thinking about what is the best way to apply the solution? Also, the terms in English are kind of confusing to me because I don't really know if they represent what I'm thinking about. I don't really know what's an adjacent vertices is. No, it's true, vertices are connected, but... Like how does these represent, like, let's say that I have a list inside of another list, and that list contains 0, 1, and 5. Does that mean that I have 3 nodes, one that has the value 0 and one that has the value 1, and one that has the value 5, and they're all connected? Or does that mean something different? I think that's what I'm struggling to understand. Like, what is the decision when you create the representation of the graph? The first is considered a column, and the second is considered a row. So just a list. The first layer is considered a list of vertices, and the second a list of edges. Now, what's the difference between? The representation methods you choose will depend on the problem you're trying to solve and the amount of information you have about the graph. Some methods are more efficient for certain tasks, such as finding the shortest path, while others are better suited for other tasks, such as finding the connected components. Graph theory: a graph is made up of two main components, vertices, also called nodes, and edges. Okay, so vertex is a node. Vertices or nodes represent the objects or entities in a graph. They can represent anything from people in social networks to cities in a transportation map. In the mathematical representation, vertices are represented by points. Edges represent the connections or relationship between the vertices. They can represent anything from a friendship between two people in social network to a road connecting two cities. In summary, vertices represent the objects or entities in a graph, while edges represent the connections or relationships between those objects. Rows and columns represent the vertices of the graphs. And the entries indicate whether an edge exists between the corresponding vertices. Yeah, so this I don't understand really well. What does it mean by this? Because that can mean that inside of the same list all the nodes are connected, or something else. My graph is represented using an adjustment. The matrix is a square matrix where the rows and columns both represent the vertices of the graph. The entries in the matrix indicate whether there's an edge between the corresponding vertices. For example, if the matrix is represented by a two-dimensional array, and the entry in row I and column J is set to 1, it indicates that there is an edge between the vertex I and vertex J. Okay, so the index determines the relationship, I think. Row I and column J is such one. Row I, column J is such one. Yeah, but then what would be the weight of the node? So if it's 0, it means that it doesn't exist, but then it can be a greater value than 1. But in this case, I assume that it's only a matrix of zeros and ones, and those zeros and ones map the relationship between the indexes of the nodes. So it's like, yeah, and the weights are somewhere else. But I don't understand this relationship really well. Yeah, if you have a weighted graph, the entry can be the weight of the edge. So that makes sense. Just trying to think about how the indices relate to the nodes in the graph in this situation. Because let's say the graph is an object, then because the node can have different values. Let's say it has a string and a value that is a weight. Let's say in the case, for example, of cryptocurrency. Let's say you have a node that is Bitcoin, and it has the value of whatever Bitcoin is at now. Let's say, I have no idea, around 22,000, 23,000. So in this case, the weight would be 23,000, but then where do you put, how does the index of the graph relates to the Bitcoin, the value of the symbol Bitcoin? That's what I don't understand. Like, where is the information stored? I guess you could have an object inside of the graph that has the information, but then, yeah, it would be the same thing pretty much, I think. So instead of having the number of the weight, you could have a list of objects, and each one has the symbol and the value, and then you use the indexes to determine the relationship between them. But that also doesn't make a lot of sense, because what if we want to put that it doesn't have but then we just put 0. It's still very tricky to think about. So how can I answer this question? Maybe I'll ask, what is the best way to frame a graph problem? And let's see what it did here. Graph algorithm is a popular method for finding the shortest path between two vertices in a graph. It works by starting at the source vertex and relaxing the edges in order of increasing distance from the source. The algorithm is often used in routing and navigation applications such as GPS systems. GPS, interesting. Create our graph using an adjacency list representation. Each node in our list should be a node name and a distance. Yeah, so in this case it only accepts 2 connections per node, I think. And then inside is the weights, and then this is the node from the neighbors. Oh, this has 3 connections, so I guess. Yeah, but why? I don't understand. Oh, it's the weight. The first number is the node, and the second is the weight, I think. Yeah, that's what's happening. I should create a list of distances initialized to infinity. Step 2. Yeah, this is common. This is the same in all of them that I saw so far. So initialize to infinity, then 0, and then false for the visited ones. Then do a nested for loop. And you see if the current one is smaller than the biggest value that it has. And if it is, it replaces the biggest value of the current one. It's kind of like creating a flag variable to... That's exactly what it is. Creating a flag variable to get the smallest value inside of the loop for all the ones in the current one. So I guess it goes, it visits, it checks to see all the neighbor nodes of the current node for the smallest value, and then that's what the value outside of the loop is gonna be. Let's have me visited. I can... Then you say true for the one visited, which is gonna contain the smallest value. And this part is confusing, but I think I get it now. Because you're replacing you with the smallest value of the nodes, or of the neighboring nodes of the current node. Then later on you make that value equals to false, but yeah, visited is here. because you're using this as a map to the graph. So it's a list of falses, the maps, the index is gonna be, you're treating the index as the weight of the graph, of the node. So you mark that as true. Oh, yeah, really smart. Now I get it, I think. So the list can be linear and have no correlation at first because it doesn't matter. You're using the nodes, the weight of the nodes on the loop to map to the list, to the index of the list, and mark as true because they were, you checked to see what's the smallest value from the current node. And then you do that on a loop because you go from the smallest to the smallest. I think I understand now how it works. But I think on this thing that I'm writing here, I'm not gonna put that. I'm just gonna leave this simple explanation and put the code of the algorithm, and then on the other one, on the archetype one, then I'm gonna try to, because I don't think it matters too much as well to explain. As the thing that I think doesn't exist a lot, and that I think is gonna be good to create of these blogs, these articles that I think might rank well, is that, and that I haven't seen, is the archetype thing, and it's not about explaining the algorithms that exist, but it's about trying to extract something fundamental about them and then create this template of thinking, let's say, this meta algorithm for thinking about problems. Instead of trying to solve the problems, you just coming up with what's the correct approach to think about a problem. But obviously it's much harder to do it because it's very difficult to think about. So obviously I'm taking a lot of time because I want to understand. I want to see if I really understand how it works. Maybe I should write down like a small description of how it works. Yeah, I'm gonna write what I talked about. I'm gonna search for how to do paragraph markdown. And so any space you give is already a paragraph, I think. Interesting. So if you end with two or more spaces, then consider this as a break. Because I think if I try to do something like the other articles I read, where it explains and then shows a bunch of code, it's just too many graphs to put on one article. It's too long. I think it doesn't make sense for this article. I think it makes more sense just a simple explanation, and then I put the code there, which I'm probably gonna copy from the other person. They used in route navigation. So maybe I'll erase this part and do something different. And this is the thing I'm not really sure. This is the length of the... I have to check to see. It's the length of the columns of the graph, I think. Or the length of the nodes. Yeah, it's the length of the nodes and then... How do I highlight this so that is false? I don't want to put the code implementation, just to write false. I think I'll leave it like this. And maybe this so it doesn't get confused with string. Code implementation is to create a list of big numbers of the length of the nodes and a list of false values. Also, the length of the nodes. As well as also the length of the nodes. And the issue with doing things like this is that it's gonna be too confusing. Because it would be better if I showed with the code of what I'm talking about here, but then the problem is that I have to put this stuff here all the time. I don't want to do that. I'm gonna write first and then I'll think about it. That's something that I'm probably not understanding correctly as well, which is this thing here. Because what if the weight is bigger than the index? Doesn't make sense to me. Because visited is gonna be based on the range, which is the number of nodes that the graph has. But then what if the weight is bigger than that? It doesn't make sense. Oh, it's making it based on the index. Yeah, I'm tripping. So it's not making u equal to the weight, it's making u equal to the index. So the index obviously is gonna be the same because it's the same length. Yeah, I think that makes sense. Then do a nested for loop to check for the smallest value of the neighbors of the current node by creating a flag variable equal to a very big number, pairing the current neighbor's value with the flag one. If the big number is bigger, the flag variable gets replaced by the current index of the loop, which represents the current neighbor. Visiting all neighbors, the index should change the visited list value. Visiting all the neighbors. List of false values. Elements of the list with false values that the index of the flag variable minus That's replaced with true to indicate the node has been visited. This process is done for all the nodes in the outer loop, returning the lists containing the values. That's That's another thing that I have to see if I can get the algorithm from this guy, because it's kind of tricky, because if I don't, then like it doesn't make sense, because he got the algorithm from someone else, because it's the same algorithm and everyone does that, because it's a known algorithm. So is that considered as plagiarism or not? I think in my mind it doesn't, but I might be wrong about that. It's kind of hard to know. Because it's a nuanced thing where I don't believe that anyone ever invents new things. Everyone discovers things. So, but there is a line there where obviously if you're just copying someone's article, like everything, then obviously that's not correct. But in this case, I think it makes sense for me to just get the algorithm, because, and obviously I can change the description of the variables, but it's still the same thing, like it's the same algorithm. So that's the reason why I think I'm gonna just copy, but I think I should research that as well. And it should be fine, I think. Maybe I'll put a reference to this, actually. I think that's a better thing to do. I think that's what I'm gonna do, and then I'll probably email them, and or maybe I should email and then ask. But the thing is that it's one of those things that I don't know. Like I don't see anything wrong with it, I think. There's obviously a limit, because let's say that I write in a blog, I make a function of sum, let's say, where I sum two numbers, and then it would be ridiculous for any other place to not be able to get that function, because I didn't invent the sum. And I think it's the same situation here, where like these algorithms exist and people didn't invent them, and even if they did, like how are we gonna tell, like someone or a business or something that they can't use the algorithm because someone else invented. It doesn't make a lot of sense to me. So I think I'm gonna run the risk. I'm probably gonna email them after and say that I used their stuff. Oh, I need to put the code here. Do I do this or not? This will be... But I'm not sure if I wanna bother. This one I don't remember if it is like this or not. No, I think it's float infinity. Yeah. I'm gonna put C's. That's simple. I think I'll worry about the rest later. One implementation should create a list of big numbers in example Python of the length of the nodes. Let's see if this is correct. A maximums, that's the thing. So I'm gonna use this floating as well. This looks like this doesn't work. Common implementation should create a list of big numbers, then example of the length of the nodes and a list of false values listed. Also the length of the nodes. You then do a nested for loop to check for the smallest value of the neighbors of the current node by creating a flag variable equal to a very big number and comparing the current neighbor's value with the flag one. If the big number is bigger, the flag variable gets replaced by the current index of the loop, which represents the current of the inner loop. Which represents the current neighbor. After visiting all the neighbors, use the weight of the smallest value, the index. Creating a flag variable equal to a very big number and comparing the current neighbor's value with the flag one. If the big number is bigger than the flag variable, let's replace by the current index of the inner loop, which represents the current neighbor. After visiting all the neighbors, you use the index of the smallest value, which was stored in the flag variable, as the element of the list of false values that has the index of the flag variable. Let me review that again. If the big number is bigger than the flag variable, gets replaced by the current index of the inner loop, which represents the current neighbor. Current index of the inner loop, the current neighbor. After visiting all neighbors, you use the index of the smallest value, which was stored in the flag variable as the element of the list of false values that has the index of the flag variable. And this is weird. After visiting all neighbors, you use the index of the smallest value, which was stored in the flag variable. As the index Oh, another thing that I'm not sure. No, I think I can do this with the parentheses. I don't think it changes anything on the markdown. Unless we have a link or something like that. Yeah, so maybe these things here, I'll have to put the code formatting thing. Because it might be considered as a link, I think. Not really sure. I think links are like, you put this and this, and then here you put whatever name, and then you put the link here, I think. I don't remember really well. But I'll change later, if that's the case. If this, for some reason, gives me a link. After visiting all neighbors, you use the index of the smallest value, which was stored in the flag variable as the index in the list of false values visited. List of the index should change the value to true because the nodes was this time. Alright. For all the nodes in the outer loop, returning the list containing the values in the end. Containing the list. Now let's see. Let's see how this looks on the thing. Heard the word of graph theory. Oh, I forgot to put the code. So I'm just gonna copy the code here from this guy. I can do on the bottom of the code, or I can do at the end of the article as well, I think. If think of references, but I think it's better to leave it here. And I think I'll probably do something like this. Let me look at the other one. Is there links here as well? I remember I did like this because I didn't know how to change the... I was struggling to figure out how to change the styling of the link. But now that I figured it out, I think I'm just gonna do it like this because it's easier to write. This is something that I've seen from the list of the other guy there. This guy, he said that it's better to leave links as to not make them open in a new tab because it's better for the ranking algorithm and for if we're doing affiliate marketing. So I think I'm gonna leave it like this, but I'm also gonna search for how to, because I think that if I wanna make it open on another tab, I'm gonna have to use the other link, the link component. So I have to use the other one probably. I think I'm gonna leave it like this and then I'll decide if I change in the future. The other thing is that I've seen that you can style the code format with a library. I might do that as well. Not sure if this is good. But first I need to style the text. I think after I finish this article, then I'm gonna style the text. I'm gonna use Medium to get the font sizes, because they know what they're doing, so it's probably better. I'm just gonna see all these divs one by one and see what styles they're using for fonts and things like that. And I'm gonna put on the theme object, the theme file here. Also I have to see, because in the documentation is not really clear on how this works, but I think, like, I know that you put 3 different values here, or however amount of values you want for specifying different responsive sizings, but I don't remember really well how it works, how each one of the sizes. I think there is a default there. I think there is something on the documentation where if you don't put something on top of here, then it considers some default values that they have there, which I think are probably good enough, so I'm probably not going to change. And then based on those default values, whatever you put here becomes those sizes as the size of the screen to make it responsive. So yeah, I'm gonna change maybe I'll look into other projects as well with ThemeUI that they give as an example to create the styles of the fonts and the spacing, things like that. I think it's better to focus on finishing the article first though, because I want to have at least one article. But I think this is good enough. But maybe, let me see. Because it would be better if I had two different styles, I think. I'm also gonna put C++ documentation, I think. Like one style here, and then should differentiate from the headlines for the link. Obviously, what I can do is put the link component, but I'm not really sure. I'm trying to think what's the best approach in the future. I guess I'm just gonna use the link component. I think I'm also gonna search for extensions. For MDX, so that is easier to write. Because that's the downside of doing things like this. I think what I'm gonna end up doing is doing a component for this, I think. But the thing I'm not sure, because I can only pass the styles in this inside of this. So that's the problem, because if I change the default one, then that's not what I want to do. Like, I'm not really sure how to pass another thing here, so I have it as a... Oh, but I guess I can pass any component, I think. As long as I pass it separately from this object here. Yeah, this is only if I want to change the style of the thing. So what I'm gonna do is probably create one here, because here I'm exporting this from these two files here. But they are using the components as well. The components object. But I guess I can pass separately. Yeah, I know I can pass separately because I did that with the image. And I also think I'm doing that with the link as well. Like the normal link from Next.js. I'm passing image and link here. Link is from TeamUI and then image from Next.js. Yeah, so what I'm gonna do probably is to create a link with the style for these kind of things, and then I just call source link, and I will create another component. Then I wrap the theme UI link with that component, and then I use that, and then I don't have to style every time I want to create something like this. Let's make really big to see if it works. Yeah, so. And then I have to think about I think I'm gonna use only these colors here, the secondary. I think this is primary or secondary. I'll figure out whatever color this is, and I'm gonna use that as the color for this kinds of links, I think. And I think I'm gonna do this after I stop, because I'm gonna stop after 1 hour and a half. I'm gonna go eat something, and then I think I'll do this thing off stream. And so this, and then I think I'll try to get an implementation in Python and C++ for each graph, and that's what I'm gonna do for all the graphs. Pretty much what I did for this one. I'm not sure how long it's gonna take me, because obviously it's difficult, but I wanna spend time on each graph because I wanna make sure that I understand the algorithm, how it works, and then at the end, so it's easier to create the other article. It's better if I understand all of them and what's common among them. Like, maybe I should be writing down as well. That's another thing that I'm thinking about. Yeah, I'll probably create a file somewhere, and then I think I'll create a file inside of this project as well, so that is everything on the same. Yeah, I think I talked about this. I'm gonna create a component, folder here called resources that is gonna map to the posts. Because in each post, I'm probably gonna have a lot of resources like images and things like that, and sources. So, and obviously I can't put on this folder because then it's gonna mess up the navigation there. Yeah, so I'm gonna stop here. I think I'm gonna do this stuff. I might come back after I have lunch, but yeah, if not, then I'll come back tomorrow. So.